So this video is going to go over what we call neutralization reactions and titrations. So neutralization reactions, you might want to have a highlighter out for this. Neutralization reaction is a reaction between an acid and a base. So up until now, we've been dealing with acids and bases separately, but now we're going to mix them together. So this is a famous reaction. Acid plus base becomes water and a salt. Just understand salt just means ionic compound in chemistry language. So acids, as we define it according to Arrhenius, acids have a hydrogen ion in aqueous solutions. Bases have hydroxide ion. And so when you combine those two, you of course make water. Okay, and that's really what neutralization means, meaning you're making everything equal in terms of the H plus and the OH minus. So we are making water and a salt. So the reason, or this equation that you see next, is usually memorized by students because it does have NaCl, which is a salt, as we know, table salt. So it's an easy one to remember. So HCl, hydrochloric acid, plus sodium hydroxide, neutralized to make water and NaCl. So the H from the acid gets together with the OH to make the water. And then you have the positive ion of sodium and the negative anion of chlorine, and you make the corresponding ionic compound. Okay, so it doesn't matter if you have two OHs or two H's, but do understand that when you're writing this equation, it's always in your best interest to write the products first and then go back and balance. Don't try to balance while you're writing formulas. So always write down water, and then you're going to put together the fact that calcium is a +2 and chlorine is a -1. So in order to write the proper ionic compound, you have a +2 and a -1. So I'm going to put it together as a 1-to-2 relationship. So CaCl2. So write the formulas first and then go back and balance. So one way you can balance is just by you normally looking at things. But another way you can look at it is I have two OHs from my base. So that means I need two H's. So I'm going to need to have a 2 in front of that HCl. I already know that because I have two Cl's over here, but it is a way for you to kind of visualize it in terms of the neutralization. So for every H, I need an OH. So if I have two H's and two OHs, I will make two waters as well. So again, however you balance it, it doesn't matter, but that is one way you can look at it. So understand when we do the math with this, all of the acid and bases will be converted to water and a salt. So we are not assuming that there's any extra acid or base in there. We're just assuming that it's all converted to water and a salt. So a generic way of writing this is HA, that is your acid. A is your anion. Okay, that's going to be the negatively charged anion. And M is going to be a metal, something from the left-hand side of the periodic table, attached to your OH, that's your base. You're going to make water and your salts. This is your ionic compound. So this, again, just another thing that you can use to kind of recognize an acid-base reaction. So pause this video and see if you could write the products to these two and then go back and balance. And again, write the formulas first and then go back and balance them. So the first one, you should have balanced a 2 in front of the KOH because you have a K2SO4 because potassium is a +1 charge and SO4 is a 2-. Realize you have two H's here, so you could use that as a tool to figure out what your charges are. And then this one, you have the same amount of H plus and OH, but because there are two, you need to put a 2 in front of the water. Magnesium is a +2, SO4 is a -2, so you put it together as a 1-to-1. So we are going to start to do some math with this. So if we look at a acid-base reaction, again, this is the famous one because of the fact that you have the production of NaCl as a salt. Please understand that you have a 1 in front of everything in this equation. So if you want to find how much acid or base you need to add to it, you could do things in a mole-to-mole relationship. Okay, so we're going to kind of go back to a little stoichiometry, not too much. Okay, So if I have 0.75 moles of NaOH, so this is my NaOH, how many moles of HCl do I need to neutralize it? So again, this is a one-to-one relationship. So I know most of you could see this, but I'm going to write it out so you have something in your notes about this. So if I want to know what is my relationship between the NaOH and HCl, I could say if I have 0.75 moles of NaOH, how many moles of HCl do I need? Well, I know for every 1 mole of NaOH, I need 1 mole of HCl. Okay, so going back to mole-to-mole relationships. So I need 0.75 moles of HCl in order to neutralize. Okay, I need the same amount. In order to neutralize, you need the same amount of acid as you do base. So if everything's 1-to-1, then the moles is going to be the same. Okay. If you have something that is not 1-to-1, like this next example, I have a 1 in front of the acid. So this is a 1 and this is a 2 in front of the base. So that one I do need to set up a relationship, again, as long as you could explain it to me. So I have 0.5 moles of H2SO4. I want to know how many moles of NaOH I need to neutralize it. So again, you're always going to have 1 is the acid and 1 is the base. So what number is in front of the H2SO4 is 1. What number is in front of the NaOH? 2. So I cross multiply 0.5 times 2, so I get the answer of 1 is my number of moles of NaOH I need to neutralize the H2SO4. Or if you don't want to do that, you could just say, okay, for every 1 mole of acid, I need 2 moles of base. So I'm going to need twice the amount of base to neutralize this acid. Okay, so that's up to you. So again, using this equation, I could take 1.2 moles of NaOH. Oops. And I could find the moles of H2SO4. So pause the video and see if you can figure out the number of moles. So you should have gotten 0.6 moles of H2SO4. So we're going to use that as a tool to do some calculations for the lab we're going to be getting ready for. Okay. So neutralization reactions are what we call titrations in terms of the mechanics or of what we're doing in the lab. So titrations are going to be what we focus on in the lab and doing some calculations with it. So a neutralization titration reaction determines the amount of acid or base needed to neutralize. So again, that's why neutralization is kind of interchangeable at this point in time for understanding this reaction. We are going to use what we call a standard solution of an acid or base to titrate an unknown concentration of the opposite. So standard solution just means you know the concentration. So it's going to be a molarity that's going to be given to you. And you're going to try to find the unknown concentration of the opposites. You're always going to be adding an acid to base or a base to an acid. You're never adding acid-acid. You're never adding base-base. For a titration, you generally use what we call indicators to see a change in pH. And so that is technically what we call your endpoint. Okay, the point where the indicator changes color is called its endpoint. Okay, so with this neutralization titration, there's usually a step-by-step process. I'm just going to generally go over it, and then there's going to be some videos that you're going to be watching about titrations. But we call it a 3-step process. So let's say I'm titrating an unknown acid with a known concentration of base, okay? So this one, oh wait, I want to do it this way. I want a known concentration of acid and an unknown concentration of base. So for this, we're going to do 3 steps. We're going to add an acid to a flask, okay? We're going to use a volumetric pipette to add to an Erlenmeyer flask. Just a specific shape flask that we'll be using. We are going to put a couple drops of phenolphthalein, okay? And it will be clear in color because this is an acid. Acids are clear in phenolphthalein. So we're going to use clear. It's going to be clear in color. And then we're going to add base until the color changes to pink. Okay, so we're going to be using a piece of instrument called a burette. Okay, so a burette is usually spelled B-U-R-E-T. Sometimes you will see it has 2 T's and then an E at the end. What you want to know is that you are looking for the phenolphthalein to change pink. Well, phenolphthalein changes pink when we get anywhere above 8.2. And 8.2 isn't exactly what we call neutrality, okay, because neutrality is where we have H plus and OH exactly equal. But again, in this step-by-step process, the turning of the pink is definitely going to tell me that I have a stopping point, okay? So this is going to be what we call my end point. This is where we're going to stop everything and not add any more base to it. So with that, that is the basic setup of a titration. Now there's going to be other videos I want you to watch that actually go through the procedure step by step so you can see it. But that's what we're doing. Have an acid in the flask, add a phenolphthalein, and add base until we get it to a pink color.